Hello, welcome back. Today let's try to solve another Leetcode problem. 300, longest increasing subsequence. So this is a LIS problem. We call it LIS. So typically we're gonna use DP for solving such kind of a problem. Now let me explain a little bit about this question. We just need to calculate the longest increasing subsequence. For example, 0, 1, with 2 and 3. So the longest is 4. You cannot find a longer than number 4. So it means we're gonna return a 4. Now let me go to the whiteboard to explain my solution. After that, I will go to the code editor to finish the coding. So this is the example 2. So we have a nums array and the output is 4. So basically we're gonna prepare a DP array because the length of the nums is at least 1. So for the DP array, we're gonna prepare the length of the DP array is the length of the nums. So inside initially, we're gonna prepare always be 1 because the DP array will be at least 1 and we're gonna return the maximum of the DP array. So the DP array, DPI means the maximum, the longest subsequence at each position. For example, DP2, it means at this position, what is the longest, what is the longest subsequence of this nums. So the second step is basically we're gonna use 2 loops. So the first loop is for checking the DP position. So for the first loop, I'm gonna use a DPR. So the first will be loop through. This is the outer loop. So for R in range N. So for the first loop, it will be, so for example, the outer loop will go from the first index. So the index, it will be this index 1. When it goes to index 1, how can it determine if it is the longest? If it is 1 or it might be 2. So for this number at the moment, the number inside the nums is 1. So for this number, we're going to compare every number before this 1. So this is 0, it is before, and this 1 more than 0, it means we're going to update the value. So how to update it? So this is 1, this is another number, this is another person. It means we're going to update it like 1 plus 1. So here it's going to become 2. So this means at this person the longest is 1, but at this person DPI, at this person DPR, here I'm going to use the DPR, and it's going to be 2 because 1 is more than 0. Then R will loop through to the next index 2. So at this position, so this is number 0. 0 is not more than 1. 0 is not more than this 0. It means here will still be 1. Then it will go to the next. Next is 3. So for this 3, 3 is more than 0. Inside the 0, it is 1. It means 1 plus 1, it is 2. 3 is more than 1. So inside 1, it is 2. So it means 2 plus 1, because here it has a value of 3. So here the longest is 2. It means 2 plus 1, it is 3. So the 3 is the longest. Even you can compare with 3 with 0. Yeah, and inside it is 1. So 1 plus 1, it is 2. So up to here, so the longest is 3. Now we're gonna go to the next. Similarly, this 2 will compare with all the numbers before it. So 3, it is more than 2. We're gonna not count. 3 is more than 0. So inside it is 1. 1 plus 1, it is 2. And 2 is more than 1. Inside it is 2. So we're gonna update it because this is the biggest. So it will be updated to 3 inside. Now this one will go to the first value, it is 0. 2 is more than 0, inside it is 1. It means 1 plus 1, it is 2. 2 is less than 3, we're gonna not update it. Now we go to the last one. So for the last one, it is 3. So it will compare with 1 by 1. Yeah, you can compare from the from this number to the first number, or you can compare from the first number to the last number before this 3. Yeah, but for me, I'm gonna compare for the first one to n minus 1. If this is r, so it will be r minus 1 to this number, because this is easier for a for loop. Otherwise, you're gonna use the for loop from the right to the left. Yeah, basically the left to right for the inner for loop is easier. So 3 will compare with 0 first, inside it is 1. So 1 plus 1, it is 2. And then 3 will compare with 1. 3 is more than 1, so 2 plus 1, it is 3. Now 3 will go to this 0 here. Inside 0, it is 1. 1 plus 1, it is 2. After that, 3 will go to here. It is 3. So 3 plus 1, it is 4. 4 is the biggest, because 3 also can compare with this 2. 3 is more than 2. Yeah, 3 is more than 2. Inside it is 3. So it will be updated to 4. Here, this 3 equal to 3. We're gonna not count. But this 3 is, yeah, I think I did made a mistake for comparing. When 3 is more than this 0, it means we're gonna update it to 2. And here, when 3 compare with 3, it is not more than 3. So we're gonna not count. And then 3 is more than 2, we're gonna count it. So inside it is 3. 3 plus 1, it is 4. So 4 is the biggest. So here will be 4. But finally, we're gonna return the max of DP. Yeah, the max of the DP array, because inside there must be a value which is the longest subsequence of the array, longest increasing subsequence. Yeah. Now let me go to the code editor to finish the coding. As I said, we're gonna use 2 for loops. So before that, I gonna prepare a DP array. So inside the DP array, it will be 1, because nums I is at least 1, as you can see from here. So the nums length is at least 1. So inside, I'm going to prepare a 1 and times n. Before that, this n means the length of the nums array. Now I'm going to use 2 for loops, because I'm going to return the max of dp. Yeah. Now I'm going to use 2 for loops. So for the r pointer, this means the outer loop. So for r in range 1 to n. So we're gonna start from the index 1, because index 0, it is 1 already we defined. So we're gonna not start from index 0. We're gonna start index 1 directly. And then we're gonna compare each number before it. So for here, it's gonna be for L. So L is the L pointer. It is always less than R. The left pointer always less than this right pointer. So for L in range R, after that we're gonna update the DP array. So we need to check first if this nums R is more than nums L. We can update it, because we're gonna calculate the longest increasing subsequence. So if it is bigger than that number, so the dpr is our final result. So the dpr should be equal to the max of dpr with dpl plus 1, because dpl is every number before this index r, and this is the longest subsequence before that. And here, if we include this number, it means we have to plus a 1. Yeah, basically this is the entire code. It's not so difficult. It is also a 1D array DP problem, but this is the LIS, longest increasing subsequence DP problem. Normally we're going to prepare a 1D array, and inside we're going to prepare 2 for loops, and the time complexity is n squared. Also, you can use some kind of a greedy method. You can calculate it using O n log n time, but for simplicity, I just use on square for this video. Maybe next video I'm gonna prepare a on times log n algorithm. Basically, we're gonna use greedy and binary search to solve this longest increasing subsequence problem. Now let me run it to check if it really works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and the time is 52% of all Python 3 submissions. I hope you learned something. Thank you for watching. See you next time.